Hi Tristan, this is Slava. Okay, so I think I know what is causing our issue, and I was able to recreate this problem today. Let me just explain you quickly what is the problem, and then we're gonna look at what are the possible solutions are. So the what we have is we have LED in general, right? So we have 12 volt source, we have LED, and then we have some circuits. So in our case, LED chaser, right? LED chaser, and it controls the current going through this LED. So it controls the current. So the maximum current through the LED that you're using is about 20 milliamps, and the forward voltage, that voltage drop here is about 2.3 volts. So this is the voltage if you would measure from here to here. You measure this voltage, will be 2.3 volts. So that's called the forward voltage. It's always kind of the same. If you apply more voltage here, it means it's going to consume more current and it's going to physically melt. But what it also means, if it drops 2.3 here, it means it's only if you would measure the voltage over here, so the sum of those voltages should make 12 volts. So here we have 9.7 volts. Okay, so this is if you connect one LED. Now the current going through the circuit is 20 milliamps, so we need to ask yourself how much power is dissipating on that circuit. So I'm gonna just take round this up to 10 volts. So the power in watts would be equal current multiplied by voltage. So we have 10 volts approximately multiplied by 0.02 amps, right? So this is 20 milliamps. So we have 0.2 watts is dissipated on this circuit. Now we have 16 channels, so multiply by 16 that means that we have 3.2 watts dissipated on this circuit with one LED per channel. Okay, and the dissipation of heat is where our problem is, because what happens when you have, instead of this circuit, now you have where is this too? So LED. So what you had today is LED. So we had the 3 LEDs, right? And then you connect them to another 3, and then you hit another 3 like this, and then it's connected kind of here, or here there's a man, and they all connect together, and this goes to the board, right? So this is what we have today. So let's quickly calculate how much current going through that circuit. Well, the current is easy because we set the current at the LED chaser. So we set it to 2 dips switches on, so it will be 60 milliamps. But how does it do it? It does it by regulating the voltage on this line to make it 60 milliamps, right? So what? So each of the LEDs is 2 volt drop. Since they in parallel, the drop is still the same. So it's 2 voltages. Doesn't matter. You know, if you measure the voltage here, it's with a voltmeter would be 2 volts. All right. So drop on this here. Same thing actually on all those circuits because they are the same. So it's 2 volts drop here, 2 volts drop over here. But those ones, those left and the right ones, they don't sum because they're in parallel. So in parallel you can connect 100 LEDs. The drop of voltage still will be 2.3 volts actually in our case. So but those 2 voltages are going to sum up. So the total voltage from here, basically from here is 2.3 plus 2.3, it's 4.6. So we know it's the today situation. We have 4.6 voltage drop on the LEDs, and whatever left was over here. So if you would measure so this goes to the ground somewhere. So if you measure the voltage between the ground and this point here today, you're gonna get 7.4 volts, approximately, maybe, I don't know, 7, maybe 7.2, 7.6, doesn't matter, approximately 7.4 volts. And we have 60 milliamps current going through that. So the wattage that dissipates to light those LEDs for each channel would be 7.4 volts multiplied by 0.06. You can do it on calculator. I'm gonna approximate a little bit here. So 7 by 6 is 42, right? So it's a 42. So it's approximately 0.042, a little bit more, I don't know, 0.05 volts. I'm sorry, watts. So this is 0.5 watts dissipation of heat, of the current produces the heat on this circuit for one channel. So now we have 16 channels. So multiply this by 16. Let me see if I can see it even. Yeah, multiply by 16. The total number we have 8 watts. And it can't support 10 watts. It can't tell you right offhand what it would support. It's the chip itself is pretty small, and it sits on a PCB that dissipates some heat, and it's copper, but it's not much. It still can dissipate 8 watts. Think about this: 8 watts would be if you take a small bulb for automotive for motorcycle use, and if you light it up at 8 watts, it doesn't produce a lot of light, but it produces a lot of heat. And if heat's gonna stay there, it's gonna collect that heat over a period of time and get hot, and the bulb doesn't burn because it's glass, but it burns electronics. Okay, so we have the challenges here. So the challenge is the lower we're gonna drop the voltage here. So let's say if we are the same conditions, let's say we don't care what the LEDs are, but let's say it's only 1 volt here. So if it's 1 volt, the heat dissipation is 1 volt multiplied by 0.06, which is equal 0.06 multiplied by 16, 66696, right? So it's equal 0.96. So it's 1 watt. Okay. So if you see, if we drop the voltage 8 times, we drop the wattage 8 times. We want to keep the voltage technically close to 0, but it's, I would say, 0.5 and 1 volt should be probably very acceptable. So this is our task, is to get to the voltage on this at this point to about 1 volt and have LEDs lit up at full blast, right? So how do we do that? Well, here's one way. It's not it's not, I think, best because I don't think there's so it's not the best because it requires you to connect. I'm going to just draw it like this, like circles. It will require you to connect the 5 LEDs, and each of them drops 2.3 volts, and we have 5 of them. So 2.3 multiplied by 5, we have 15, 5, we have 10, 11. So we're going to drop 11.5 volt, which is perfect. It's going to only leave us 0.5 volt here through our circuit to go through, and that will dissipate a little heat. The less voltage here, the less heat. Now. The challenge is there that it's mechanical, I think, challenge, your design channel challenge. If you can create the packs where you're using 5 or 10, 15 LEDs for each channel, because you can connect another 5 of them like this, another 5, and it will just increase the current. So instead of 20 milliamps, you get 40 milliamps, but it's still 40 milliamps and 0.5 volts. It will be, so if you have, the wattage would be even smaller. If you multiply by 0.4, you're getting only 0.02 watts, almost nothing. But the challenge is you have to do it in a quantity of 5. So you have to do channels by 10 LADs or 5 LADs. So you can't do 8 or 9, because then you can't just take one off. You can't just do it like